All right, so this is our last section of notes. We have it broken up into two parts. This is going to be part one, and we'll cover part two at a different time. The basic objective here is to find the measure of angles using a new postulate called segment addition postulate. So you'll add that to your arsenal of reasons for your proofs that are soon to come. And also you'll learn to identify special angle pairs by naming angles, measuring, and classifying them. You'll need to know that kind of stuff for when you make equations. So if you know two things add up to 90 or two angles add up to 180, if they're equal, and so on. So I'm going to try something new with our angle definition. I'm going to try and type it. So let's see if I can get this right. So an angle basically is a figure formed by two rays that have the same endpoint. Let's see if I can spread that out. Look at me, I'm getting tech savvy over here. All right, so that's a little bit better than you guys trying to read my handwriting. So down here, now you guys are gonna write a little slower than I might type, so just pause me and then we'll move forward. So this right here is a ray. So you have two rays, I'm sorry, this is an angle. Here's the two rays. You have ray GC and ray GA. They both have the common endpoint G, so that's why it's called an angle. So name the angle below in 4 different ways. Well, when you name an angle, you always want to have the vertex in the name. This right here is the vertex. It's that middle point where the two rays come together. It's that common endpoint. And when you name it just using that vertex, you would just say, for instance, angle G. You put that little symbol in front, little angle symbol like that. And then you could also name this angle CGA or angle AGC. So it doesn't matter which way. Now if we had a little number in front here, and your picture I might have a slightly different picture than you, I'm not sure why, but if you have a little angle number, you could also name it angle 3. Any of those ways is fine, or you could use the word angle, but why type out or spell out angle when you can just use a little symbol? Geometry is all about symbols. Now the only time you could not use this situation would be is if you had multiple angles that shared the same vertex, like in example number 2 over here. Notice E is the vertex right here, and angle 1 and angle 2 have E as their vertex. So if I named that, hey, whoever, angle E, that person that you're speaking to would not know if you're talking about angle 1, 2, or the whole thing, okay? So it's really important that you are very descriptive with your names and you name things properly. So with this little roller coaster, it asks you to name the different angles in the picture below. So got to kind of think outside the box. You have, and write these as I say them because I'm not going to have enough room, so I'll just say them. You have angle 1, you have angle 2, you have angle with the little symbol AEC, you have angle DEC, and you have also angle AED or DEA, whichever way you want to write them. The main importance is that that vertex, the E in this case, is in the middle of your name. As long as that's in the middle, it doesn't matter, because that tells the reader what direction you're going with your angle. So if you tell the reader angle AEC, they know you're starting at A, moving in E's direction, and going up through C. If you said angle ECA, that's not an angle, ECA. Okay? It doesn't work that way. So make sure that that vertex is in the middle of your name. And don't forget to write with your angle symbol. So angle 1, try and fit them. Angle 2, angle AEC, angle AED is that whole thing. Or you can switch those letters around, the A and the D, just keep the E where it's at. Or angle CED. Now, I'm going to just tell you guys these things little bit by little bit. When you're doing this stuff, don't just randomly write down what I'm saying. Like, try and make it make sense to you, okay? Now I'm going to move this up, and it looks like my little stuff is going to move too, so that's no good. So I guess I could delete this stuff maybe. At that point, I guess I can delete it. Maybe it'll, I don't know how to make that stick. I'll have to work on that. Anyway. Ways to classify angles. Most people are familiar with this. I haven't had a class that wasn't yet. But in this example, this is an acute angle because it's less than 90 degrees. So we would name this acute. And we would describe it as an angle that's between 0 and 90. Notice that we don't have the little equal symbol underneath. It's not this. That's a no, because it's not equal to 0 and it's not equal to 90. Those have their own names. And if it was equal to 90, it wouldn't be an angle, so that wouldn't make any sense to us. This one, hopefully you're shouting out right angle, at least in your head. So that is just equal to 90, which is why the other one, the one previous, does not have an equal sign on it. Hopefully the third one you already know is obtuse. That means bigger than 90, but less than 180. So the angle's measurement will be bigger than 90. Oh, not equal to, my bad. Let me erase that. Hopefully you caught that before I did. Oh, let me grab this color. So greater than 90, but less than, oh, I did it again. Oh my God, I'm going to kick myself in the behind. I just really want that equal sign for whatever reason. And I'm trying to erase with a big old stylus. Less than 180. And last but not least, we have the straight angle. Basically, it's a straight line. If you put straight line, that's fine, but its degree measurement is exactly 180 degrees. All right, so example 2, it says use a protractor to find the approximate measure of each angle and identify each as acute, obtuse, right, or straight. Well, I'm sure most of you probably don't have a protractor sitting around your house, but if you do, you can give it a go. I'm just going to explain how you would do this. You'd put your protractor on, and you're going to have to extend these lines because they need to hit your the protractor, which I have an example coming up that I have a protractor sitting there. I don't think it's on this page, no. So we'll get there. You would extend like lightly with a ruler. You wouldn't have a raggedy line like mine, but you would extend it so it would hit your protractor marks, and you would take the difference of this measurement and this measurement, and hopefully without even doing that you could see that it's an acute angle. This one looks to be about 90. That little box in there shows us that it would be 90. And hopefully you're saying that this one's obtuse and it measures about 140 degrees. For the next one, here's a protractor. So what I was saying about extending your line is if you extend it like out like that, but you would definitely want to use a ruler. You don't want to just freehand it because you'll mess it up. And extend this one. You can see where it marks. Okay? And that gives you a more accurate measurement as long as your lines are straight. Mine are not, so I would not have an accurate measurement there. So, well, I was trying to erase it. Apparently it doesn't want to let me. Alright, so anyhow, it says there are 10 different angles in the picture above. Name each angle and determine the angle's measurement. Then classify each angle as either acute, obtuse, right, or straight. So let's start with the angle measurements, or the angle names rather. So I see angle, we'll call, what is that going to be, O? This one right here, we'll say that's O. Angle AOB, and I also see angle AOC. We'll just go down the line like that. And angle AOD. And angle AOE. So we got 4 out of 10. Moving on to the B1, we have BOC. So now we're going to do some examples. What is measure of angle TSW if measure of angle RST is 50 and measure of angle RSW is 125? So these are just words if we don't put them in the picture. So let's do that. So let's figure out what we're looking for. It says TSW. So TSW, this is what we're looking for. So let's put an X there. You can put a question mark if you want, but an X is what we'll be using most often. They tell you that RST, this right here is 50, so let's fill that in. And they also tell you that RSW is 125. So I like to do that and put a 125. So hopefully you can see where angle addition is coming in here. We have 125 and we have two numbers, 50 and an unknown, that add up to be 125. So you just have to make your equation. 50 plus x equals 125. Subtract the 50 from both sides, and x equals 75. All right, now it doesn't ask what x is, it asks for the measure of this right here. So we need to figure out, well, that is the measurement, but so you guys know sometimes these will be like 2x. You figure out what x is and you got to plug it back in. So just be aware. So in this case, x is 75, and that is also our TSW. Okay. All right, moving on to the next one. If the measure of angle DEG is 145, what is the measure of angle GEF? So let's fill in what we know. This is 145. And we are looking for GEF. Hopefully you're looking at this angle right here. Remember, the middle is the vertex. And we don't have another number. So many students get confused at this point, like, oh my God, what do? You don't have enough information. Well, you do, because what kind of angle is this? Hopefully you're saying straight angle, and that's correct. So you want to say 145 plus my unknown is equal to 180 degrees, which is a straight angle. Subtract the 145 and you're left with x equals, what is that, 535? And it wants the measure of angle GEF, and that is the measure of angle GEF. Now for the next one, it says, suppose measure of angle 1 equals 42, and measure of angle ABC is 88. Find angle 2. So, well, we don't have little numbers here, so we got to write them in. This is angle 1, this is angle 2. So angle 1 is 42 degrees. Angle ABC, which is the whole thing, is 88. What is angle 2 going to be? Well, we have to say measure of angle 1 plus measure of angle 2 should give me measure of angle ABC. That's angle addition postulate. So fill in what you know. You know that this is 42. You don't know what this is, but you know that this is 88. That's substitution. And then subtract your 42 from your 88 and you are good. Now I realize you guys could do that in your head, but again, I'm trying to somewhat prepare you for proofs. So 46 degrees. Okay, so that is where we're leaving off for part 1. I hope we'll cover the rest of them tomorrow, but this is what you would do for this part 1. I told you it's a lot of information. Okay, so we'll cover part 2 tomorrow in class, and be on your way. Hopefully we'll still have the test on Friday and it'll be done. Have a good one.